Welcome guys, this is a very quick overview of the lessons from last term, but my biggest suggestion is actually to go back and read the full PowerPoints and read your full notes and watch every video. But this is a very quick summary. So our first lesson was on atomic structure, and here you can see that there's protons in the center with the neutrons. They're inside a nucleus, and surrounding there we have electrons. Now, I just firstly want to point out our first definitions. We had elements. So it says an element is a substance which cannot be split into simpler substances. Okay, so that's like carbon, hydrogen, oxygen. Anything you find on the periodic table is called an element, and it can't be broken into simpler substances. They're made up of one type of atom. You have to learn this definition off by heart. That's your first job. An element, which are found on the periodic table, cannot be broken into simpler substances. They're made up of one type of atom. So then we decided to say, well, what actually is an atom? And it's the smallest particle of a chemical element. So the smallest part of lithium, sodium, any of these is an atom. It's the smallest particle that can exist. Atoms make up all matter, and we know that they're made of smaller subatomic particles. Okay, so if I put the video on, and you might want to create some summary notes yourself. Okay, so here we've got an atom. There we go. Atoms are made up of subatomic particles. Okay, they're made up of protons, which have a positive charge. They're made up of neutrons that have a neutral charge. And atoms are also made up of electrons, which have a negative charge. Okay, so we have our atoms. Okay, these are made of subatomic particles. Even further above that, if we look at the definition we just talked about, we have elements, okay, which are found in the periodic table. Elements are made of atoms. I'm going to say made of one type of atom. Okay, so for example, if we look at the element hydrogen, made up of one type of atom, which is a hydrogen atom. Okay, atoms are made up of subatomic particles, protons, neutrons, and electrons. Protons, which we can write as like this, protons have a positive charge, neutrons have a neutral charge, so we often write a 0, and electrons have a negative charge. So we write that with a little negative symbol. Now I'm going to draw a very basic diagram at the moment. This is not a Bohr diagram. This is a very basic diagram of an atom. In the middle, we have positive subatomic particles. These are our protons. Also in the center of our atom, we have neutrons, which are approximately the same size. They're slightly larger than a proton, but they're also located in the center of the atom. Now I'm going to attempt to draw these electrons a lot tinier. Okay, and these electrons travel around the outside of the nucleus. Okay, so again, protons have the positive charge. Our neutrons are also located in the nucleus, but they have no charge. That's why I don't have a symbol there. And electrons travel around the outside of the nucleus. They have a negative charge. So again, just to remind ourselves, the center of the atom is called the nucleus. There we go. Okay, so that is the center of the atom. Okay, so that was a lot of the first lesson was made up of learning that content. If we just go back to the first lesson, I'll just triple check. I think the other thing is, looking at size and also looking at reading the periodic table. So I'm just going to go back to the camera. Okay, if we want to talk about the size of these subatomic particles in comparison to each other, if we look at size or mass, but mass is more accurate. Okay, so if we look at the mass of a proton, okay, it has an atomic mass of what we call 1. Okay, so it has an atomic mass of 1. Our neutrons, if you can remember, I said are slightly heavier or have a slightly greater mass than a proton. That's not very good language. Okay, so they have a mass slightly greater than 1. Okay, and then our electrons, I don't like the language I used. I'm just going to go back up here. Okay, atomic mass slightly greater than 1. So we say that's slightly greater than a proton. Okay, so I'm going to get rid of that and say they have an atomic mass slightly greater than 1. And then our electrons, like I said, are very tiny, and they have a mass of 1/2000th the mass of a proton. So they're 1/2000th the mass of a proton. So that's looking at those mass of those subatomic particles. Protons have an atomic mass of 1. Neutrons have an atomic mass slightly greater than 1. And electrons have a mass that's 1/2000th that of a proton. Again, this is just stuff that you have to learn. All right. So that's looking at mass. Okay. And then this is looking at what are atoms made of. That's going to require study because it's all brand new stuff. The next thing that the first lesson looked at was reading the periodic table. So if I'm going to pull up the periodic table here, okay, this is the one that you should be working from. This is the one we gave you in class, and it's also found in lesson 1 of the OneNote. The reason we've given you this example, now there is one in your diary which is you're more than welcome to use. The good thing about this one is they have rounded this bottom number, which is year 8, you just want the rounded version. So if you use a periodic table that says, for example, 6.99 instead of 7, you just have to remember to round that bottom number. But it's best to use this version. This is the version you'll also find on your exam. Okay, so we have to be able to read what do all these numbers mean, and we need to be able to interpret that. So if I pull, so let's have a look at, for example, lithium. Okay, has a number 3 at the top, has a symbol Li, and it has the number 7 at the bottom. Okay, so I went ahead and drew what we get from the periodic table. So just to clarify this here, I just drew the element lithium from the periodic table here. Okay, so the number at the top is called our atomic number. Okay, here for lithium, its element symbol is Li. You'll notice with element symbols that if there is two letters, the first letter is a capital and the second letter is lowercase. Here, lithium, well, that's our element name. Okay, and the number at the bottom on the periodic table is the atomic mass. Again, this is stuff you just have to learn. It's new, okay, and that's why you're learning it, so that it will soon become familiar. Okay, for lithium, the atomic number is 3. What does the atomic number tell us? The atomic number tells us the number of protons. Okay, that's what that number tells us. It also tells us the number of electrons in what we call a neutral atom. In grade 8 science, we are only dealing with neutral atoms, so we're just going to keep it as simple as the atomic number tells us the number of protons. The atomic number also tells us the number of electrons. What does the atomic mass tell us? It tells us everything in the nucleus. In the nucleus, hopefully you remember, we find protons and neutrons. Okay. So the atomic mass, because remember, most of the mass is coming from these protons and neutrons. Electrons are so light. They weigh 1/2000th of protons. So we don't really care about that weight or that mass. So the total mass of an atom is really in that nucleus where we find the protons and neutrons. So important to remember, atomic mass is the protons and neutrons. How is this useful for us? Okay, so if we're going to look at lithium, well, lithium we now know has how many protons? Okay, well, the atomic number tells us the number of protons. The atomic number for lithium is 3. So we have 3 protons. How many electrons does lithium have? Well, the atomic number also tells us our number of electrons. It's 3. Finally, how many neutrons does lithium have? Well, we know the atomic mass is protons plus neutrons. We know that lithium has 3 protons. So 3 plus what gives us 7? 3 plus what gives us 7? 4. So we have 4 neutrons. Another sum you can do, which is a little bit quicker, is you just do the atomic mass minus the atomic number. Same thing. Okay, so for neutrons, we have 7, the atomic mass, minus the atomic number, which is 3. So 7 take 3 equals 4. That's 4 neutrons. Okay, so that is reading the periodic table. We just go back to lesson 1. I think we've covered everything, which is great. It's really good for you to go and practice that step with a couple of other atoms from the periodic table. Lesson 2 now, if it wants to load. Again, was a little bit of a review of what an atom is made of. We talk about isotope notation, okay, which is something a little bit new. So we're going to go back to the camera and now look at isotope notation. I'm going to keep these notes handy because they're going to be useful. I'm going to look at isotope notation again with the lithium example. So isotope notation is just a different way of writing what's on the periodic table. Okay, you can't see that. There we go. Okay, so I'm going to write isotope notation here, and over here I'm going to say the periodic table. Okay, so we're going to do isotope notation versus the periodic table. Now on the periodic table, we just learned that lithium is written like this. There we go. The number at the top is called what? Have a think. The number at the top is called the atomic number. And what is the number at the bottom called? The atomic mass. So that's how the periodic table is written. Hopefully you also know this is the element symbol and the element name. Isotope notation is just a different way scientists write what's on the periodic table. For some scientists, they prefer this way because once you get used to it, it's a lot quicker. With isotope notation, what scientists do is write the element symbol, and then what they do is they write over here up the top, they actually write the mass, so the atomic mass, which is the 7, and then down the bottom they write the atomic number. It's just a different way of writing what's on the periodic table. Some scientists actually prefer this version. But you still need to know that in isotope notation, this number now at the bottom is our atomic number. And this number at the top is our atomic mass. It's just a different way of writing what's on the periodic table. And then here, well, this is our element symbol. It's just different. And you just need to know that if a question on the test said, write notation, this is what we would be looking for. If we quickly look at fluorine now. Okay, so I've written fluorine here. This is what it looks like on the periodic table. If I was to write it as isotope notation, we write the symbol F for fluorine. We write the atomic mass at the top on the left-hand side, and we write the atomic number down the bottom. There we go. So that is isotope notation for fluorine. Again, just a different way of writing what's on the periodic table. You just need to remember that the smaller number is the atomic number and the larger number is the atomic mass. Okay, going back over lesson 2, it's really important that you do that as well. You'll notice there is a practice worksheet that I strongly suggest if you haven't done it, then go back and do that. Okay, if we look at lesson 3, it is all about Bohr diagrams. Okay, so I'm just going to pull up the camera. Alright, so since we've got this information here, we're actually going to draw a Bohr diagram for both of these elements. I'm just going to move this page down. So a Bohr diagram is a way of drawing an atom, and it was developed by the scientist Niels Bohr. Okay, now like I said before, when I drew this atom, very, very basic, we're not going to draw this structure. We need to learn how to draw a proper diagram, a Bohr diagram. All right, with lithium, I'm going to cheat and use our notes from before. We said that lithium has 3 protons. That's that number from the top. With a Bohr diagram, you start off by drawing a nucleus. In the nucleus, we have protons and neutrons. We learnt that up the top here. So how many protons does lithium have? We said it has 3 protons and we said it has 4 neutrons. So I just pop that information in there. That's easy. What we now need to draw is our electrons. And this is where it gets a little bit different. What Niels Bohr discovered is electrons actually exist in what we call electron shells. So I'm going to draw my first electron shell here. Okay, so I'm just going to edit this diagram. This is called the nucleus. And then this is going to be our first electron shell. Some textbooks and some videos don't call it an electron shell. Some call them an energy level. Okay, so this is the first energy level. What we know, and it's something you're going to have to remember, is that in the first electron shell, we know that 2 electrons can fit in there. Doesn't mean that 2 have to be in there, it just means that only 2 can fit. We know that in the second electron shell, I'm just going to do those little symbols. In the second electron shell, scientists know that 8 electrons can fit in there. Again, 8 don't have to be in there, but that's all that shell can fit. And in the third electron shell, again, only 8 can fit. I can keep doing this. Scientists know that in the fourth electron shell, 18 can fit, in the fifth, 18 can fit. But in terms of what we're going to get you to draw in year 8, we're not going to go past 3 electron shells. Okay, so we know with lithium that I have to draw 3 electrons altogether. This is my first electron shell. I've got to check my notes. How many electrons can fit in the first shell? Only 2 can. So I'm going to draw my first electron, and quite often you'll draw that second one down here for that first shell. Only 2 can fit in this shell, but lithium has 3 electrons, so I have 1 left to draw. So I'm going to draw a second electron shell. If I've drawn 2 electrons, lithium has 3 altogether. I've got 1 left to draw. Yes, 8 electrons can fit in that second shell, but I only need to draw 1 because lithium only have 3 electrons altogether, 1, 2, and 3. So I'm going to write on here that this is my second electron shell. Okay, so what I'm going to do now is quickly look at the Bohr diagram. So this was for lithium. Let's have a look now at fluorine. Okay. So fluorine, whenever I draw a Bohr diagram, I just need to first figure out how many neutrons, protons, and electrons in fluorine. Well, we know the number at the top is our atomic number, and it tells us the number of protons. It also tells us the number of electrons. So fluorine has an atomic number of 9, so that means it has 9 protons and 9 electrons. We know that to figure out the number of neutrons, we do the atomic mass minus the atomic number. So the atomic mass is 19, and the atomic number is 9. 19 take 9 is 10. We have 10 neutrons. Alright, now I've got to draw my Bohr diagram. First step, draw your nucleus. And in a nucleus, we know there are protons and there are neutrons. How many protons? We have 9. How many neutrons? We have 10. Now I need to draw my 9 electrons. First electron shell goes in. How many electrons fit in that first shell? We know 2 can fit. So I'm going to go ahead and draw those 2. I've drawn 2, I've still got 7 left to draw. No more can fit in that first shell, so I go and draw a second shell. Okay, so like I just said, we've drawn 2, that means there's 7 left to draw. How many electrons can fit in this shell? Second shell can fit 8. So I'm good. I only need to draw 7 though. So the way that you draw it on the first shell, you just go down, up and down. When you draw it on the other shells, I usually draw my first selection at the top. Then I go around the roundabout. So 1, 2, 3, 4. Okay, remember I've got to do 7 on this one. 5, 6, 7. Okay, and we often draw the dots in pairs if we have to. All right, so let's count. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've drawn 9 electrons, so I know I'm correct. Okay, I had done other Bohr diagram videos in the lesson 3 on the OneNote that you should have watched last term. If you're still struggling, I suggest you go back and watch those examples. But this is a summary from lessons 1 to 3. I suggest that you copy these notes, pause the video and copy these notes as I went through. Hopefully that helps.